All right, welcome back. I hope you all had a chance to get enough for lunch and didn't eat too much though, so you'll fall asleep during my session here. I wouldn't want that.
We can soon wake them up. Okay.
So if you guys start drooping or falling asleep, Richard's going to walk around, bop you on the head, wake you up. So welcome back. We're going to continue talking about desired state configuration. This is going to be a little less code and implementation heavy and a little more theoretical things to consider, but we can dive into whatever technical part of it you guys might like. Again, I like questions throughout, so if you have questions as we're going, I will try to break at the end for questions, but if you have questions as we're going, don't hesitate to ask. I'm more than willing to do that. And then for those of you who might just be joining us for the first time, I'm Steve. I like PowerShell. I like desired state configuration, and I help run websites. And you can find more about me at either on Twitter or at my blog. So we're going to talk about the PullServer. And the PullServer environment is the environment that if we're working with DSC, we should be working in. There are numerous advantages to running with the PullServer in a PullServer environment. What is our alternative? Well, we have the PullServer, but we also have this command start DSC configuration where we can push a configuration to a machine. Well, that sounds great because I can control when that happens. Well, there are a bunch of downsides with that as well. Number one, you have to actually imperatively tell a machine to go get a configuration. But if you use any custom resources and you're using start DSC configuration, you are responsible for getting those custom resources to that machine and the appropriate versions of those resources to that machine. There's nothing there to help you with that. So that is all on you. The other thing is it's a much more manual process than a PullServer environment. So the PullServer environment puts the onus on your client machines or your servers that are that need to be configured, on them to go get their configurations and apply it. And because it's their responsibility, they can actually also go to that same PullServer and say, "Hey, I'm missing a custom resource. I need this particular version. You got it for me?" And if it's there, they can pull it down from that location. So most people say, "Hey, that's all well and good, but I can't stand up. I don't control IIS in my environment, or I can't stand up this. I don't have server 2012 R2 web server that I can use. I've got WMF4 some places, but I can't stand up a PullServer." The PullServer is not just the REST-based endpoint. You can use any file share as a PullServer. So you just have a file share that you point to, and you can stick your configurations and their checksums and your resources that are zipped up appropriately out on this file share and have your machines point to that. So I can't stand up a PullServer. If you can't access a file share somewhere and have a couple of folders, then you can complain about it. But if you're in that kind of environment, I don't know if I could thrive in that environment. But and you have my sympathy. But the barrier to entry for a PullServer is very, very low. You just need a file share. Now, if you can do the REST endpoint, that's good, because now your transport mechanism's HTTP or HTTPS, and it can be a little more firewall friendly. You don't have to worry about SMB across different network links, that kind of thing. But you have a couple of options there. So we're going to talk about a couple of these topics here. Some of the considerations around a PullServer environment that make this a more scalable, a more team-friendly, and a more controlled environment. So one of the first things that I came up against when I started working with desired state configuration is the fact that I want to have my configurations generated the same way, no matter who on my team was making configuration changes. And I didn't want them to have to rely on me making a change and generating configs to push out. I didn't want that, because if I'm out, say I'm here and they need to make a change, are they going to call me and, I got a VPN in and make some changes? No, we need to have a standard way that other people who are not me and who haven't spent all the hours on it that I have can be able to do and replicate the same stuff. So first order of business was creating a build script, and I'm using some of the more developerish terminology around here, because the workflow is very much like software development. The desired state configuration falls into this realm of tools that fit into this infrastructure as code space. And so we apply a lot of terms and practices that we would see in the software development space to managing our infrastructure. So my build script is going to be the script that actually goes and starts creating my configuration. So it needs to load up my configuration data. If you joined me in the last session, we looked at that a lot. And it needs to be able to call the configuration function to generate all of the MOF documents. It also might need to validate or test my resources to make sure they're valid and package them up to be distributed, and maybe push out some other tooling or something along those lines. But in order to make this process not reliant on me, first order of business is creating a build script. And I can show you what I actually, and I'll show you and I'll walk through in a few moments here what build script I ended up having, and I'll share a version of that in a future blog post on PowerShell.org at some point in the near future. But what standardizing on this meant is I needed to make sure that in this script I included all of the requirements to generate my configs, regardless of what machine I'm on, regardless of what the state of that machine looks like, that it needs to be able to make sure that, okay, we've got the latest versions of X, that they're in the PS module path so that the configs can be generated properly and that they get deployed to the proper location. So let's take a look at build script here. So I started.
What are you using to interact with your script to check any source control? What do you use?
All right, so good question here. So all of my DSC related stuff is checked into source control. We were using Mercurial hosted on Killen, and now we're running our own internal GitLab. So I just moved from Mercurial to Git. It doesn't matter what source control you use. You should be using some source control. I'll hammer on that shortly more. But one of the and this is where the build script kind of comes into play, is I use a build server to generate the official versions of the configs. Nobody on my team should be generating configs on their local machine and pushing them into production. They should be editing the documents, testing locally, and then checking in their changes to our source control. When a change is checked into source control, our build server is watching it. So who here's used a build server in some way, shape, or form before? A couple folks. Okay. Who here's used some kind of orchestration engine, like System Center Orchestrator or something like that, or some workflow engine? Okay, a couple more. The build server is just a cheaper version of an orchestration engine. They do the same thing. They just have different names on them. A build server orchestrates a bunch of steps. Now, the nice thing about a build server is it has really good integration into a variety of source control systems. And since source control is very important in this process, build server is a good fit for generating my DSC configs. So what happens is one of my team will check in their changes, and the build server is watching that repository. When it sees a change comes in, it kicks off the build script, pulls down the pulls down the changes from source control, kicks off the build script, and goes through and does all the generation. And if all the tests pass and everything checks out hunky dory, it pushes that stuff into production. So, I'm sorry, could you refresh me on the exact? I kind of started going around. What was the?
I was just curious what you used. Do you have a plugin that you were using with ICE, or you're just using?
Oh, the command line clients. I use the command line clients for. So when I after I make changes, I'll in the case of Git, I'll do git add to the files that have changed, then commit, and then push. Okay. So that I'm not hooking anything into my editor or anything. Those are separate steps. And then the automation's triggered off of changes coming into the team repository. So changes locally aren't going to trigger anything, but changes to the team repository actually start making changes. So I put together a build script, and I'm not going to go through every little bit here, but I'm just going to point out a couple things. One of the first things it'll go and do is it makes sure that latest versions of all the tools that do all the nice functions like the resolve configuration data property and stuff like that are actually available on my build server. Because when I check in my configurations, I don't know what server this is going to run on. I've got like 10 or 15 different build agents in my environment that are capable of running these configurations. So one of them, whichever one's not busy at the time, is going to get the job. So I need to make sure that the current versions are all located. So I recently switched over to using Chocolatey to do this. And so I have an internal repository, which is just a file share, because file shares are easy, where I have my package tooling sitting. So the build agent will pull that down, and then it will load up. It loads up my configuration data, and then it loads a module that has my DSC build module that has a lot of build functions. And that DSC build module, if it's not already on GitHub, it'll be there shortly. But I believe some variant of it's there already. But that has a bunch of functions then for actually going through and executing the build process. So, and the reason that's separated out there is so that people can run these steps locally and test for failures and things. So we have a build script that kind of starts and kicks things off. And it drops into here we go. This invoke DSC build command in my DSC build module. And this just has a bunch of steps. Clears out any installed DSC resources because I need to make sure that I'm going to use the latest version out of source control. Clears any cached resources. So this is something that came up during the break, but the WMI process will cache the versions of resources that you have. So if you're running or trying to generate a config and it looks like it's using an old version of a resource, kill the WMI process. So I'm just kind of brutal about this, and regardless, when I run a build, it kills WMI, all the WMI processes, and then moves on. Then run my unit tests, and then now depending on, now I can do these builds, I can do just tools or just resources, so some of these might run, might not run. But this is just the workflow that runs through. Runs unit tests, copies the current, as long as the unit tests pass, it'll copy those current ones to the program files, Windows PowerShell modules, so it's on PS module path, so that my custom resources can be leveraged in my configuration. Make sure that the targets that I'm going to be writing my configurations to are actually there and valid, because if you don't have directories there, it might be a little problematic to write files to them. And then generate the configurations, and then do all the packaging to get them to where they need to be. So one of the things with packaging resources for a desired state configuration, I'm just going to quickly highlight this. Your custom resources, when they get packaged to go on to go to a PullServer, whether it's the SMB or the REST endpoint, our package is a zip file with stack exchange or with the name of the module _ module version.zip. It has to follow that naming pattern. And then you need another file alongside it that's a checksum of that file. Now, fortunately, they have a new, they added need some wildcards there. They added a command, a new DSC checksum command to generate the checksum files. Early on, this command did not exist, and so you had get file hash, which would get you the checksum. But if you used out file or set content to write the checksum file, it'd be invalid because those two commands add an extra carriage return, and the DSC validation would actually blow up on that. So you had to call like IO write all text, IO system IO file write all text or something. I had some function to wrap that. So you wouldn't get that extra carriage return. So to make it easier on us, they give us a function to do that. So this is something that catches people up when they're trying to deploy resources. If you take a look at the DSC build module out on GitHub, it will give you an example of commands that you can use to package it in this format, so you don't necessarily have to reinvent the wheel. All right, I talked a little bit about source control as well. So the build script kicks off, packages things, pushes them out. It just does all the orchestration, and you can run that. The way I have it in my environment is you can run that locally. You can test to local folders. You can stand up VMs and push to them. And you can do all this testing before you actually check into your source control, where now the changes can go live and it can get pushed. Now maybe they're going to go to a staging environment in your environment, or maybe they're going to go out into production like in mine. But you're going to check it into source control, which our build server watches. In my case, we're using TeamCity. There's a variety of build servers out there. You could use other orchestration engines. You could have a scheduled job. There's a variety of things you can do to do this. I found build servers work very well for this. And for the most part, they're inexpensive. There's open source ones. TeamCity is relatively cheap, I think. I know the build agents licenses are. And then one of the things that this has made, one of the challenges that this has come up is making sure that when I write my commands, or when I write the commands to do this stuff, or when I write resources, or when I write configuration documents, that the stuff isn't relying on things that are available thanks to my user context. And that the process of going through and doing that makes it so much easier for someone else in my team to replicate that environment on their system. So it's a bit of a pain up front, because you don't necessarily know if something is happening good because it's in your profile or it's in one of the modules that's being auto-loaded behind the scenes. So going through the process of setting this up so it can run as a job on some other machine or other random machines makes a huge, huge difference as far as how quickly other people can get up to speed with your build process or with your configuration generation process. One of the other considerations that we have to deal with is if we are operating in a PullServer mode, because that, I think, should be the default that we go to. If we're operating in a PullServer mode, how do we control the rollout of configurations? How do we, if we have an environment where I don't want the new changes to go out to everything. Some of this comes back to our configuration data that we looked at in the last session, for those of you who were there for that. We can kind of target nodes with particular bits of data, and so maybe I might have a pool of machines. For example, in my environment, we're building a monitoring system, and I have a little service here that all of the most recent build of our agent for our monitoring system gets deployed to the listed servers, and other machines get the latest production release. So we'll get a handful of machines that get the test bits, the rest get the development bits. By breaking out where those go, I can push changes regularly, and only the servers that should be affected will be impacted by that. Rather than pushing that one change live across my entire environment. The other thing you could do is you could set up your build process to target specific instances and filter down to particular groups and only generate those configuration files that affect the machines that you want to target. Those are a couple of options you have there. Another scenario is maybe I have a configuration change. Yeah.
So in that last example where you showed all of those endpoints, those nodes that you're going to be generating ops for, how in a PullServer environment, how are you managing the conversion of that to GUID?
Good question. What in my node data, so this is the service documentation that says, okay, hey, these are variables for this particular feature. In my node, wrong. I have a mapping. So I have the name, and I have the node name, which has the GUID.
Okay. And then from a pushing the DSC pull configuration to the node, you also have to match that GUID. You have a
yes. Yeah, so one of the commands in my DSC operations module is set DSC client. And what that does is it uses configuration data to look up the node, get the settings, and push the local configuration manager setting to that node. So we leverage the configuration. I'm using the same configuration data store to drive configuring the local configuration manager and generate. I can use the site data to determine whether to look at which data center to focus or to point to for its PullServer and that type of thing. So.
And that's something that automatically get kicked off from your build server.
So the set DSC client is part of my server build process, or my server installation process. So we stand up, spin up a VM or spin up physical hardware, and one of the steps. So instead of if this is a Linux server in my environment, we would log into the Linux server, run Puppet agent test. That would generate a cert request, and then we'd have to sign it on the Puppet master, and that kicks off. And then now Puppet works for the Linux machines. The equivalent for our Windows setup process is that's a manual step on the Linux side. On the Windows side, we can run set DSC client. You give it the name of the computer, and it creates a sim session out to configure the local config manager. So that's an interactive step. And what that does is that stamps the machine with the GUID it needs to go look for its configuration and where to go check in. And then it can go pull what it needs to have, and then I can just let it go and it'll fix itself.
So what I'm playing with doing is using the GUID from AD.
Pardon?
What I'm playing around with is using the GUID from AD.
Yep.
So you stage your computer in AD, and then you have the GUID already. So you could actually stage it, like if you're using WDS, you have the GUID, you can generate your config for it, but already to go by the time it boots up. Okay.
Yep. And that's nice handy option. And then you don't have to store that, and you could read that out of Active Directory then to when you're generating your config data or something. You know, there's a number of solutions for that. All right. So we build, we have some tools in to operate this. So what happens when we have a change that needs to go a little more synchronously? So I make my edits to my config documents, I push them into source control, my build server generates the configurations and deploys them to the PullServer. What if this is something that is I'm trying to deal with a config issue that's causing an outage? Since I'm in a PullServer, do I have to wait for that PullServer to pull that config and go to work? No, you know, if I run start DSC configuration and try to push that configuration to a node, you will not be happy later on. Because what that will do is that will actually change it will actually change the local configuration manager settings. Even though you're not specifying anything, it will flip it back into a push mode. And it will never go look again for a pull configuration until you go reconfigure that node. So anytime, if you have a node configured for pull and you push a configuration to it, it will flip it out of pull mode completely. So how can we do this in a little more interactive sense with a PullServer? There's a sim method that we can poke. And it's let's see here, DSC operations, invoke DSC pull. So there is a sim method called perform required configuration checks. And we can reach out and touch that, and that will kick off a consistency check. So there are two types of consistency checks that happen with the DSC agent. So the local configuration manager has two settings. One is refresh frequency minutes, and the other is configuration mode frequency minutes. By default, the refresh mode frequency is 15, and by default, the configuration mode is 30. You'll notice it has a nice multiple. Configuration mode frequency, you can set it to whatever you want, but it will always be the closest multiple of your refresh mode, so that the configuration cycle happens on one of the refreshes. So what's a refresh? The refresh is when it looks at the configuration document that's been assigned to the computer and runs through and checks everything. Make sure everything's in the state that it should be in. So in the case of this machine, if it was in pull mode, right now it's in push, if this was in pull mode, every 15 minutes it would check the document that's stored as the local configuration and validate the system settings are in the right place. If not, it would try to fix things. Every 30 minutes, it would go out, so every second check, it would go out to the PullServer and say, hey, you got something new for me? If not, I just go check what I have. If you got something new, I'll pull that down. If I need new resources, I'll pull them down. And then I run through the check. What this means is if you want to force, and my production settings are actually 15 minutes on the refresh and 60 minutes on the configuration mode refresh. So there's 3 cycles of local checks and then a check out to the PullServer. I'm actually considering changing and going back down to 30. It really hasn't been that much of an issue. Yes?
So does the configuration mode play into that at all, since it's set to apply and monitor?
Yes. So good point. So since I don't really do any configuration against this desktop, I do it usually against a virtual machine or stuff. There are different configuration modes. I will address those very shortly here. So the configuration mode frequency, though, because there are multiple checks in a row, there's actually a file that tracks what state they're at. So after the first one, second one, third one, and then in my case, my production systems, every 4th check it'll go to the PullServer. So there's a little state tracking that it has. But when the command that I run, that that sim method that we poke, that's the same sim method for both checks. It just tracks where it is state-wise. So if I want to pull from my PullServer, I might have to poke it a couple of times before it actually does what I want it to do. And there's a couple of flags you can throw to it. I think 3 is the value that we actually want. But this function too, you don't have to remember this stuff. This function's also out in the community repository. And you can give it a verbose flag, and when it runs through the config check, not the consistency check, not the shorter one, not the one, but when it runs through the config check, the full config where it pulls the local, it'll actually run through and give you all the verbose messages about everything that's applying. So in my case, every 4th check would give me the verbose messaging for that. In any case, the stuff ends up in the logs. I wish there was a different flag I could throw at it to say go to the PullServer without having to kind of walk through and finish out the cycle each time, because it could be anywhere between 1 and 4 cracks at the can before it'll actually do what I want it to do. And there's not an easy, unless you go look at the file system on that machine and look at the configure file underneath there. There's not a good way to know exactly where you're at. But as it stands now, there's not really a different option. So, okay, and it's now came up the configuration mode. By default, you will be in apply and monitor. Apply and monitor will apply a config the first time, and then it just reports back if you deviate. This is usually not what you would expect. What you normally would expect from how you hear DSC talked about is that something deviates, I go and fix it. So there are a couple of different modes that you can be in. There's apply and monitor, and then there's apply and autocorrect. Apply and autocorrect is the setting that you would normally want. If you just want to try out DSC to provision and kind of see how it would work in your environment, apply and monitor might work for you. Apply will only work on the first application of a new configuration. So if you either push or pull a new configuration, it'll apply. If you change something, until it gets a new configuration document, a changed configuration document, it won't change anything under apply and monitor. It'll just tell you that, hey, this is different than what I should be.
Apply and monitor, it just writes if there's a delta or whatever, it's local logs, right?
Yeah, just in the event logs. Yeah, so the logging is the next thing I wanted to bring up. So the local configuration manager logs to the event log. There is a custom event log for desired state configuration, which is under the new style event logs. And so it only logs locally. So you delve down into Microsoft, Windows, and there's a little spot for a desired state configuration. There's an operational log that's always running. There are debug and analytic logs as well, but you need to turn those on. They don't capture any messages until you turn them on. But that's where your debug and and a lot of your verbose messaging can end up. There's a community resource that the PowerShell team kicked off called DSC Diagnostics. So the XDSC and the CDSC Diagnostics module. That has a command that will go through and aggregate those DSC logs for you. So it actually aggregates for an individual run of the consistency check engine all of the log messages relating to that. It is not a fast command, especially if that log is very full. because it can take a little time to assemble those things, because it's got to look for the right GUID everywhere. But that is very handy when you're troubleshooting something on a remote machine. But it can only log what log messages you give it. So if you need additional logging, write verbose in your resources as your friend, as well as if you hit any errors and you're looking for the error that was thrown, you will find them in this event log. As I mentioned earlier, if you're in the PullServer mode, there is no such thing as a non-terminating error. All errors will cause a termination in operations. If you're doing the push mode where you do start DSC configuration, it will actually roll through non-terminating errors, report the non-terminating error, and continue processing. That is not the case in the pull mode. That is one difference in how the local configuration manager operates there. So you need to be very explicit about error handling. Yes?
And I think you started to talk about operation, how you deploy these production servers, and maybe you stop. But if you get to a state where something has failed, right? Do you have any automation in here to fix servers out of your NetScaler or BigIP, apply changes, if it succeeds, put them back into rotation? How do you manage the network end?
Yeah, not yet. That's on my list. That's one of the things I want to do. That's something actually we're working into our build process as well. But I also want to check our load balancers before it takes it before it applies changes that would impact, like say updating the application or updating one of the web apps, to check to make sure that there aren't too many servers out of the load balancer before it takes itself out.
Because the next step is how you do continuous deployment with the DSC method.
Yep. So I'm doing continuous deployment, but I have to be very conscientious about the changes that I deploy if they're going to kick off reboots and things like that. Now the load balancer will see, oh hey, there's something down, but it's not going to. I need to put some checks in there so that the processing doesn't start until the environment is safe for it. So that's definitely something that I need to implement there. And have a resource that things depend on, and say, okay, none of this can progress until my environment is stable enough for me to take this node out. Yeah. Now, if a node gets wedged, I've had this happen, where there's two scenarios where I've seen just once processing has failed, no matter what you do, it doesn't seem to want to restart and come back to life. Rerunning my set DSC client, which clears out any configured MOF documents, kills the WMI process, and reapplies the local configuration manager settings, has usually fixed that. Where it hasn't has been when there's Windows updates that don't think that they need a reboot, so they haven't rebooted the box. But there's a bunch of pending file renames and things like that have thrown the DSC process off, and a reboot of the machine has resolved those. So there are two scenarios I've seen where the DSC process doesn't, or the local configuration manager hasn't been able to kind of roll through and kind of fix that scenario. There's a few other things I want to mention here before we run out of time. So we got logging there. Don't have time for that. So a couple of things that we want to make sure that we don't have in our PullServer environment is that we don't have magic machines or magic people. If I get hit by a bus, my team should not, or if I end up out at the bar too late with you guys, I shouldn't. My team should not be hamstrung because of that. So the process needs to be bulletproof enough to run outside of whatever custom environment I've crafted. The other thing, this is what I really want to address here, the securing credentials and secrets before we run out of time. So DSC provides a mechanism using certificates to encrypt credentials from when you generate a MOF document out to the client. and can then use public key cryptography to encrypt the credentials out, and then the client can decrypt them and use the credentials for whatever purposes it was designed for. That's all well and good if you're generating all the config documents locally on your own machine and then pushing them to a PullServer. However, I just finished telling you guys that shouldn't be the way you operate, and that sets you up for this kind of magic people, magic machines kind of thing where the configs probably generate on something or probably rely on something specific to your machine that you can't easily replicate elsewhere. So how do you secure them if you need to check those things into source control? What I've done is something similar to what DSC is doing and use certificates. So anyone who's editing a configuration data and wants to add credentials, they have a certificate with a public key that the build agents have the private key for. And so they can encrypt the credentials on their local machine. We add it to a credential store, so an encrypted blob ends up as a file in source control. And then only the build agents can decrypt that, and then when they generate the configs, they'll re-encrypt it out to the clients. And in the DSC configuration module that I have out there, there's examples of the commands that will generate or that will do that encryption and store them and decrypt them as part of the build process. And so I'm definitely open to hearing other suggestions for ways to manage credentials out to a build agent. We looked at at encryption with Active Directory security groups and some of the APIs around that. Certificates seem to be the path of least resistance, especially since we're already doing some stuff with that.
I'm not sure I understand. So all of the clients who are pulling have the public key that can decrypt the creds? So
all of the clients that would need to get those credentials will be configured with the private key to decrypt them. So now, and they can be different keys. What I use to get it to my build agents can be a different public-private key pair than what the DSC configuration generation to the DSC local configuration manager. That can be a different key pair, and nothing says that all of my clients have to have the same key set. I can use multiple pairs of keys, so my web servers can only decrypt passwords that matter to web servers. My SQL servers can only decrypt passwords that matter to those boxes. So you can definitely segregate who can see what, and then you have a separate key pair for those people who are adding credentials to the repository. And then the build server then have a key that they can actually they'll need to be able to access all of the creds for their process, and then of course removing the file, anything that was temporarily there.
This then implies that if any of the clients compromised, whoever compromised it can retrieve the creds and decrypt.
Yes. I mean I don't know. At some point, these things that have to end up in memory and be able to be translated down. There's no other way to move credentials between machines. I'm definitely open to hearing some better ways to make that more bulletproof. But at some point, these things need to end up in memory on the build servers, because otherwise, you are stuck generating and relying on people to generate the machines, and you can't put the workflow and process to, if you need to put an approvals process in between your editing out to your distribution, that's your point to do it. And so we need to have a way to securely distribute those credentials. But the build servers that these run need to be able to decrypt those things. And of course, the far end clients you can segregate so that they can only see the creds that matter to them. And they're only going to get the credentials that are in the MOF document that describes their configuration. So my SQL servers will never see my app pool account passwords. My Web servers will never see my SA password that's being configured for my SQL servers, other than the web servers that are also build servers. And they'll only see that in the build process context. All right, I am going to wrap up here. If you have further questions, I will actually step out into the hall because now I actually have to give up the podium for a little while and let somebody else talk. And I want to thank you guys for your attention, especially those of you who have struggled through with me since earlier this morning. And if you have any questions, I'm here all week. And I'm more than happy to talk through any scenarios or so that might not be clear or that might be particular to your domains. Thank you very much.